Okay. So you have two triangles here, and they kind of look like they might be congruent, but not sure. Right? So we want to check that they're congruent. Then we want to figure out what was the transformation that mapped one to the other, if they are congruent, which they're going to be congruent. And then I want to pick a point down here. I don't know, something like, how about the point 7, 0? And we're going to ask, well, what does that transformation do to that point? So where does this point on the first triangle land on the second one? So first, let's just show that they're both congruent. Now, there's several different ways of doing this, but since we're in the coordinate plane and we're mostly dealing with lengths, we're going to pick side, side, side. So we're going to show that all three sides are congruent. If all three sides are congruent, then the angles are also congruent. We've talked about this before. All right, so I'm going to move down here. I'm just going to have the two triangles separately. So I have this side here is 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 6, and 8. And we should recognize this as the 6, 8, 10 triangle because it's 2 of the 3, 4, 5 triangles. That was the larger version of the 3, 4, 5 triangle. Up here we have 4, 3, so 5. Recognize that as the 3, 4, 5 triangle. And here we have 2 and 11. So I'll have to do that one. That's going to be 2 squared plus 11 squared is c squared. 121 c squared. So this one is square root of 125. So let's go next door here. This one is just 10. This is 5. Get that by counting spaces. And then we've got 10 squared plus 5 squared is c squared. I think we can see where this is headed for now. So this length is square root of 125. So each side over here is the same length as its corresponding side over here. So the two triangles are congruent. All right, so that we know. Now, what was the transformation that maps one to the other? Appears to be a rotation. So it looks like this one just got turned up here by some angle around a center of rotation at A, which is the point 0, 0. Now the question, what happens to this point 7, 0? Well, currently, 7, 0 is on this leg of the triangle. It's a right triangle, by the way. You could check that by looking at the slopes of these two sides. They are negative reciprocals. This one, by the way, is slope CD, or CB, is negative 3/4, and slope AB is 8/6, which reduces to 4/3. So, anyways, so at this point right here, 7, 0 is on that leg, and it's 7/10 of the way out. So we need to find what point is 7/10 of the way out on that side there, which we can use this slope to calculate. There's several different ways of doing this, but one way is to look at, I don't know, we could do, hold on a second, I'll decide. Alright, the easiest way is to think of this as if we think of the vector that goes from A to B, so it's the vector, say over here, the vector 6, 8, and we want to find a vector that is 7/10 as long, right? Because we've got a vector that goes from AD, and we want to find the point that's 7. That's 10 spaces altogether. 7 spaces over would be 7/10 of that whole length. So I want to find a vector that's the same direction as this, but 7/10 of the length. And so I would just multiply that by 7/10. And so that's going to give us the vector, let's see, 42/10 and 56/10. I can reduce those two fractions. So that's 21/5 and 28/5. Right, 56, 28, yeah. So let's see, 21/5 is a little bit over 4. So let's see, that's 1, 2, 3, 4, and just a little bit more. And 28/5 is just a little bit under 6. 1, 2, 3, 4, 5, 6. So the point's right about here. Would be the point. 21/5, 28/5. And that's where this, if we were to follow this rotation, would end up. So this is 7/10 of the distance from A to D, and so this here is 7/10 of the distance from A to B.